Hello explorers and welcome to another video. Today we are going to deep dive into WebAuthn. And I really like to do these kind of deep dives into the technology in order to figure out if it's something that I should use or it's something that I feel safe to use. And I really want to understand every piece of the technology. That said, it's not probably the best way of implementing this. Probably you should use some kind of library that already implements it for you, but I did most of it by hand. If you want to support this channel and these kind of deep dives, there are links to affiliates and to a donation link in the description. So let's switch over to my screen here. We have a register passkey and a login with passkey. So these are buttons that just do what they say, and they will run some JavaScript in order to do some work, and then we will have a PHP backend. So let's switch over to the code here. So we have these buttons first. Then we have two kind of functions here that are required because the different technologies that are using these WebAuthn could be like a key or other things that are physical. So you need to have a very rigorous kind of format. So we would need to take this from an base64 key in some cases to an int8 array byte, which is a byte array pretty much. So it will take these base64 encoded strings and make them over to a byte array. And the same goes in the other direction, take a byte array and make it into a base64 key. So those functions are there, so we can use them. And in some cases, they are using base64 URL encoded, but I have chosen not to use it except for when it's actually required. So in some cases, the device will create it and then we will have that problem. So here we have the first, when we register, we will run this register challenge PHP. So we will get the challenge back and then we'll get these options and we will use those. So let's look at the challenge. It's very simple. In here, we will take this config file where I have the domain, for instance, and then we will create a new challenge, which is a random 32-byte array. And then we will create this RP. And this is the definition of this domain. So it's pretty much the domain and the name of the domain. And then we have a user here, and it needs an ID. So you will probably pick this ID from something that you create and put into a database. And then you have a name, and this could be an email address, for instance, and a display name. So this is the current user. And I have chosen to hardcode these, but usually you put those into the registration form so you can add them here. But I have chosen to hardcode them at this point. And then we have this challenge that we put in here to the public key thing. And then we have some parameters. We say that we want to have a public key and we want to use the algorithm -7. So that is the encryption algorithm. And we will go more into that later, but that is one of them and the only one I support at the moment. And then we have authentication selection, and then we have resident key is required, user verification is required. So you can choose to have these turned off if you want. And then we have timeout here of 60 seconds. So that's how long we wait for a response. And attestation, we said none. In case where you have these kind of banking or other kind of tools, you can add attestation in order to have even more rigorous checks who the user actually is. But for this use case where we're just logging in, attestation is not required at all. So when we come back here, we will get the user ID, we get the challenge, and we will create a public key that is those two, but we need to change these from this byte64 key in order to read them on the other end in the device. So those goes over to byte arrays instead. And then we will use the navigator, credentials, and create a new credentials. And we send in this public key here. So that is how you actually initiate the talk to any other device. This could be something built into your operating system or your password manager or any other device that you are using to get a WebAuthn token. And when we are run this, we will get some data. So we will check this cred object. We will set the ID here. We set the raw ID, and this we move from an ID over to a base64 array, a base64 string, and then we have an attestation object and a client JSON, and those also we change over to base64. And then we have the credential type. And we send all that data over to register response, and we will post that data, and we will get a response back, and we just alert that response back. So if we check at the register here, it's pretty much taking in the data that comes from like a JSON object up here. We will fetch the client data JSON and the attestation object. Then we have this base64 URL decode, and that is because the ID that comes, not the raw ID, but the other ID will be base64 URL encoded. So in order to check that, we will have that function here. It's nothing serious here. It just pads on the extra in the end, and also changes over the data from minus and underscore to plus and slashes. Probably the last part is the only thing that is required, but it's a full implementation there. Then we have a function here to take some bytes and create an UUID. That is something that I will check later, so we can see that it's the right kind of device. It's not required, but I thought it was a pretty fun thing to do. And then we have something to create actual key later on. So we will come to that. But first we take this client JSON here, and we will check the type. So we will decode this JSON here, and then we will check that WebAuthn create is what we want to do. Otherwise, we will fail. Then we want to check the origin that comes in, and we will want to see that that is our domain. Otherwise, we will fail. We don't allow cross origin. This is when you are using iframes and so on. I don't want to mess with that, so put that to false, or else we will fail. And then we have this challenge, and of course this challenge needs to be the same as the expected challenge in the session, or else we will fail. Next up, we have something really interesting. We have this attestation object, and that is encoded by CBOR. So they have chosen in this committee, which have created this, so it's a bunch of people and everybody had their say, to create a bunch of extra stuff in order to secure this. So if we look at the guide here, we see that we have a pretty simple guide to go through, and this is if you're using a particular backend already, so you already have a bunch of plugins for this. But if you want to implement this yourself, you have a list of 25 objects you need to check in order to have a secure connection. So there is a bunch of text here, and the people that have written this have, of course, gotten paid by the word, so it's very lengthy and a lot of information. And if we go over to next part here, when it comes to CBOR, of course, this is a specification of 66 pages in order to implement CBOR, and it uses something called a major type. So it's a type that is just a couple of bits, and then there is a length, and then is the actual data. And it's a way to compress things in a very peculiar way. But here you can have integers, you can have negative integers, you can have strings, you can have text, You can have arrays, maps, and tags, and so on. I have somewhat implemented that, not a full implementation, but a bit of it. So what I was talking about earlier here was the CBOR, and I have this CBOR Lite implementation, and it has those types here: unsigned int, negative int, byte, text, array, maps, tags, and simple or float. The two last ones here, I wasn't bothered to actually figure out what they actually meant or implement, so I haven't implemented the full spec, so this is a light version. Only what I need. So for the first ones here, then we need to figure out how to get those. And when we get in here, we will check the offset here, the first byte, and then we will get out the first byte, the first 3 bits of the byte. That's the major type, and the other ones are info. So in this here, we will take this info and check if it's less than 24. Then we will just add that value. Otherwise, we will take the next byte and put that in if it's exactly 24. If it's 25, we'll take the next 2 bytes. If it's 26, next 4 bytes. And it's 27, the next 8 bytes. So those are the ways of fetching a particular value. And then if it's the major type is negative, then we will return it as a negative int. If the major type is a byte string, we will return this as a byte string. So we will take this and take the length of the thing that we got out up here, the value, and then fetch that. And if it's a string, we will fetch the string value here instead. Yeah, it's the way of fetching these things, and then otherwise we'll just return this value down here. So that's the way of parsing a new token. It's a little bit convoluted, but the thing is that they have split the first byte into 2 pieces, and then depending on what the type is or what the value is, you can fetch the rest of the data. Next up, we have this CBOR array, and it's also depending on the type. Of course, the first ones here, when you just have a string, a byte string, or so on, you can just return those values as is. And of course, this byte string, I also base64 encode it, so it's readable. I think in JavaScript they create a buffer instead, but this is the way that was easier for me. And then if it's an array, of course, we will need to go through all the values here to get all the values into array. And then if it's a map, we need to fetch them in pairs, key value, and then put them into a map. And when we do that, we will get a Java get a PHP array out, and then we can use that in order to create a JSON or whatever we want to do. So that's the CBOR. We will get that back. We will get an offset if we want to fetch even more data, but in this case, it's the last part of this. Then we'll get a JSON back, or an array back, and in that array there is something called auth data. And I'm not sure if I had that in the specification here. So this is the auth data that you get back. So you will get a format, an auth data, and attestation information. But as we said that we don't want to do attestation, we only are interested in the auth data. We will get this back. And in the auth data, you will have the current domain here, shard 256 hash. So the first 32 bytes are a hashed value of the domain, and then we will have a bunch of flags here. It's mostly if this is backed up or if the user is present and so on. The only one that I was interested in is if there is attested data included here, and then you have a sign counter here where you can check so you don't get multiple signs on the same session key, for instance, and so on. So you know that this is the first one and not the second one, and so on. And you can allow more, of course. So what I do here when I get the attestation data, I get this RPID out and check that the domain is correct. So I hash the domain and check against that. And I also fetch the flags here and check that there is attestation credential data available. So I just check that flag there. And then I get the sign bytes and the sign count here. Don't really do anything with that, but I just needed to add up so I know what it actually is. And then I will take the attestation credential data and I fetch all of that into a new variable so I know that I start new, because that is a different byte sequence. And they say down here that it could be this credential data variable if present. They don't know how long it is. And then they have extension as well here. So they have, of course, another definition of this. So here we have that attestation data, and it starts with this AA GUID, and this is the authenticator. So then you can see who is actually trying to authenticate with you. And I fetch that as bytes and then put that into an UUID, so I can actually check that later. I thought that was funny, so I have actually printed it out here in the file. Then we will get the credential ID length, so we know how long the ID of the credential is. And we fetch that, and then we will take that ID out. Also something that I print out down here. That is important, so we can actually use the same ID to fetch that ID from the database and send that over so the user can log in, because this is the ID that is actually used in the sign-in process. And then we have the credential offset, which is after this ID. So it's the 16 bytes of the AAUD, the length of 2 bytes, plus the length of the credential ID. So 18 plus the length. And this is, of course, a CBOR again. So we put in this credential data and the credential key offset, and we will get a credential public key out. And this key is very strange, and I print it out here as JSON as well. But it's a bunch of numbers as keys, and then a bunch of numbers or a sequence as values. So the first thing we check here if the data is not the credential ID, of course, so that could be put a little bit further up, but then the client ID in the attestation credential data is not correct. And then we will take the public key and we take -2 and -3. Those particular values are the X and Y of this key. And that will create an easy point on this curve. So we put those two together, and then we will put that in to create a PEM that we can use for the actual encryption later on. And this function is pretty straightforward, right? Creating a PEM. You have the algorithm here, which is a very particular key. If you Google for this key, you will find the definition that this key is hard-coded. It must be this header in order to be this key. So that is straightforward. I don't know why they chose exactly those hex bytes, but that is the hex bytes that you need. And then you put the particular point that you put into here, and then you will check the length of this bit string here and put that before the bit string. And then you take another bit string here with a bit string length that has both the algorithm and the bit string length and put those together. So it's pretty much just a way of baking it all together into a long string. And then with base64 encode that sequence and chunk it up and create this public key. This is something that I just asked ChatGPT to give me. It gave me this, except for this ID. This ID was wrong. It gave me another ID. I Googled for that. Nobody had seen it anywhere. So it just made something up. So I found this key using another function. So Googling a bit, and I found that key. So that is what we do, and then we will get all this data into a file. So let's actually do the logging now. We will register a passkey, and there it comes. I use Bitwarden, and then we will save passkey as a new login. Boop. And it says okay. So now that we have done that, so we have a key, we can switch over and check this file that we have created. So let's go here, and we will cat the passkey log. So here we first off had the credentials up here, so the credential ID in two different forms. And then we have the AAUD, and this is something that I want to check out in a list. So let's take this and then switch over here and then try to find it here in the list. There we have it. So it says that it's Bitwarden. So this is something that they choose. And there is a bunch of other authenticators you can use here. So if you're curious, you can store this value and then check what did they actually use to authenticate the last time. So it's just some extra information. And you could also say that some of these are not allowed. Check the particular value and then say, okay, this password manager is not secure enough. I will not allow it. So that's a use case for that. Then we have this public key. And here we have 1 equals to 2, 3 equals to -7, -1 is equal to 1, and -2 is this key, and then -3 is this key. So 3 is the actual algorithm. It's -7, and that was what I said earlier that I wanted. But this is, of course, also defined in another of these kind of specifications. So here you have a specification for how this header should be, and here you have a bunch of values, and these are not correct. So this is what they say that the header value should be, but it doesn't really add up to what I found. But there is another definition in WebAuthn where they show these. So you have the 1 is equal to the to key type, and then you have 7, which is the algorithm that I use. You have the curve, which is 1, and then you have the coordinates here. So I don't know what the other specification was for. Then there is so this is 1952, that specification. Then you have 9053, which defines more information here about the different key things. So here you have signing algorithms. So you have 3 available signing algorithms. And later down here you have a 4th that you can use. And then you have a bunch of message authentication code, MAC algorithms, and so on. So there is a bunch of things to implement here depending on how much of this specification you want to handle. But I think that just implementing a couple of these would be required for my use case. And just as an example, I only implemented one of them, this 7. And then we have the public key here. So that is pretty much the first part when we log in. So this is when we register. So we have a bunch of data there that we can store into the database. Either we will store the just public key and the ID, or we can also store the and some information like an email or something that someone can write in to fetch that data. Or we can store these two X and Y and then create the key later on if we want to store less in the database for some odd reason. So that was a bit of a hassle. That took me a long time to figure out and be done with. But now that we have a key, the signing process should be easier, right? So the login, it will fetch a challenge as we did before as JSON. If we look at this challenge, it's pretty much just another of this byte array here. That's the challenge. So this needs to be different every time. It's very important that this is a different amount of keys every time. And then you have the domain and allowed credentials here. So this is the stored credential ID. So I had another one here. So let's go back and take the new stored key here. So let's copy paste that in where it should be. There. So now we have the new key. So this is something that you fetch from the database when you actually have that information. And then you said that it could be either internal or USB, so this is where the key could be stored and fetched. And then you have the user verification is required. So I need to verify that you are you, and then you have 60 seconds to send me a response back. Of course, we will have the same auth response here. So here we will also need some changes. So here I have these kind of curve X and Y. So I would need to copy those, put those in here. Otherwise it will not work. Like that. And we will take the other one. Equal sign at the end there. So now I put in those. So now I should, if I haven't forgotten anything, be able to do the sign in. Log in with passkey and choose this one and log in successful. So it works. So what did we do now? Now that we got that credential challenge into this login function here, we will of course move the challenge over to the public key. We will move over this allowed credentials as a map with the credential ID. And then we will do this assertion. So credentials, get, and the public key. So now we will get an assertion back that we can check if this is correct. So this assertion, we will take the ID and the raw ID, exactly like we did before. We'll get an authentication data, a client JSON, and a signature. And the signature is the important part that we want to check. And then a type. So of course we could do as we did before and check these values and have a bunch of that checking done. But the important part is the signature that I want to check. So if we go back to the auth response here, so here we will get all this back here. So we will have the auth data, the client data, and I fetched also the signature, and we have the raw ID. So here I will take the client JSON and create a hash of that. And then we take this auth data plus the client hash, and that is our sign data. This is what we want to sign and see that we get the right signature of that data. So it's pretty straightforward. We want to see that everything that you have sent me is correct. And then we can use that data, that client data, in order to actually figure out who you are and let you into the system. So we have this stored key that we have fetched because we know in this session who you are. We will get X and Y, and then we will run this function here. And you see that I have this PEMX.2. So this is the one that I run with the right ID. I have also saved the old one with the wrong ID. And if we check the difference here, the wrong one starts with 300 and this starts with 301. I have no clue where it got this one. It's fairly close, but totally wrong. So very strange. So we run this, we will get the PEM key back, and then we just run OpenSSL verify with the signed data, the signature, and the PEM key, and using the OpenSSL algo SHA-256. And if it says this is okay, then you are logged in successfully, and you can let the user into your system and give him access to every service that you want this user to have. So this was my deep dive into this. Of course, I didn't implement my own crypto or anything like that. You should never roll your own crypto, but everything around these kind of authentication protocols where you're talking back and forth should be easily understood and something that you could implement yourself. And I think they have done themselves a real disservice here by making it so obtuse and very randomly complicated, I would say. It doesn't really need to be this complicated. You could use just a byte sequence. The data doesn't really grow that much. So I don't really know why you need to use CBOR at all. And other things that they have chosen back and forth here that makes things just strange and hard to comprehend. But it was something that I wanted to go through and figure out, how does this work? Is it secure enough for me to use? Currently, I just think it's obtuse and not really adds any extra security. So I wanted to use it because I really don't want to handle people's passwords. I don't really want that responsibility. But I'm not sure if this is the right solution. If you have any comments or suggestions or think differently, leave a comment in the comment section down below. If you haven't subscribed yet, please do that. If you like this video, give it a like, share it with your friends and colleagues, and I really hope to see you in the next video.